Okay, so today we are going to talk about a topic that you'll increasingly hear about it. So, in the last few years, 3, 4, 5 years, there is a huge attention to generative AI, the large language models in AI. uh, uh, there is an area that, from a research perspective, not entirely new, but it is getting an extensive new attention. That's because after you know this, what is called as data is the new oil kind of thing that you might have heard of. Now people recognize that data alone is not enough, and hence you they are saying, what if we were to use knowledge to improve our computation? And I would say that, in broadly, this issue of using knowledge in computation is not just limited to the current AI. So even if you are not interested in the AI per se, you'll find that any computational, any decision making application, you will potentially see the role of what we are going to discuss today. So in that context, and this is a very good example of the kind of research being done by by our students, and certainly in this case happens to be a PhD student. We play a very leading role in this general area in the world. So with that, I'll pass it over to Joey.
Hi everyone, welcome to this class. So my name is Joey, and I'm a PhD student under Dr. Shet's research group. So the title for this seminar today is the is data and knowledge-driven processes for the knowledge graph lifecycle. So before we go deeper, so let's look at this diagram here. What exactly is knowledge? What do you mean by knowledge? If this is a DIKW pyramid: data, information, knowledge, and wisdom. So at the bottom layer, this is all where our data lives. So if you look at this example here, if you look at any data set that mention a value of 150, without the right context, without anything, we just couldn't do anything with just the value data itself, 150. But then if you surround it, you put it with the right context, systolic blood pressure of 150. Now you annotate the data with some sort of label using external knowledge. Now we know that, okay, so this 150 value means systolic blood pressure. But at this layer, this is still an information layer. But what exactly are we going to do with this information? So we move on to the next hierarchy called the knowledge layer. So 150 systolic blood pressure could mean elevated blood pressure. So now we get a little more knowledge about this value here, 150. And then if you do any form of deductive reasoning, you probably will get up to the this person might experience some form of hyperthyroidism based on just the 150 value from the data itself. So the 150 itself doesn't tell much, but if you traverse up the hierarchy and incorporate external knowledge, we kind of get a sense, piece together that, okay, this might mean hyperthyroidism in this context. So this slide is just to show that knowledge plays a very critical role in intelligent computing. We use the knowledge that we curate, the human experts curate, to associate meaning to data, to make sense of data, making the data more interpretable, and to support planning and more complex tasks like reasoning and analysis, and then ultimately decision making. So let's take a step back and see what exactly is a knowledge graph. So knowledge graph itself, in essence, is a graphical format of representation of your knowledge. So in its simplest form, it is represented as a triple representation where you have a node called a subject. In this case, is non-alcoholic fatty liver disease, and then that is a subject. And then you have relationship. What is it connected to? And in this case, my relationships are risk. What are the risk factors? And these are the different risk factors associated with this subject. So in essence, this is how knowledge is being represented computationally in a knowledge graph format. So of course, knowledge graph has been increasingly used for a wide variety of downstream applications, like question answering, summarizations, text simplifications, yada yada. So there's a lot of role of knowledge graph being played here in modern systems. So not only that, a lot of big industry enterprise, they started leveraging knowledge graph to support a lot of downstream use cases as well. So some of the big known knowledge graph, for example, link open data, and then we have schema.org. Interestingly, LinkedIn knowledge graph, it's also there. So how would you tell that, let's say in a scenario where you are connected with person B and person B is connected with person C. So then LinkedIn will have his backend knowledge graph to kind of look through the connections and between you and person C, and both of y'all have a mutuals between person B. So it might suggest you that, okay, you might know person C just because they are modeling the entire network as a form of graph. And even knowledge graph itself, if you search your Google search bar for, let's say, Apple, and you can see there's a knowledge card that pops up on the right hand side where you have all the information about Apple and then all the key relevant information all summarized to you in a very nice detailed tabulated form, like customer service number, who are the founders, founded the headquarters, who are the CEO. All this information are big is actually part of a knowledge schema that the human experts has already curated and just put it in place to deliver this kind of knowledge for you in a snapshot at this time. And it is all powered by knowledge graph behind the scenes. So why knowledge graph has been increasingly getting attention is because we, even though like modern data-driven systems like deep learning and also like ChatGPT language model, they are very cost efficient and they can learn complex patterns. It's just because the modern generative AI systems, they are not silver bullet in nature because they are world model like temporal, spatial, and also their reasoning and understanding of the entire environment are highly dictated by the underlying input data. So as you all know that machine learning, deep learning, it's a blank model. You have to feed in input data for it to train, and then you generate a response. So the quality of the output is determined by the quality of input data that you put in, and also indirectly shape the entire world model of the inner workings of that language model. So which is why we are facing a lot of risk like biases, hallucinations, or even misinformation. It's because the model itself is specifically trained on the input data. If those input data it's of bad quality, and hence you are seeing a lot of different bad outcomes and also bad results. And yeah, taking a step back, just to open up the box a little bit and see how current language model works. So essentially, language model like ChatGPT, they are basically a token prediction engine. Like for example, when you ask what is Mark Zuckerberg net, and then so it's trying to predict what do you mean net worth, salary, rich for. So all these words surrounding so like net worth, salary, rich for, they're all being represented in a 3D space or even higher dimension. In this case, I'm just showing 3D because it's conceptually easier for everyone to actually visualize and see. But it is actually stored in a very high dimensions, 128 dimensions or even 1,000 dimensions, and they're all represented in the vector space. And so what the LLM is trying to figure out is what are the closest surrounding concepts that are similar to net worth when the word is being mentioned. And then it dig around and found that salary and rich for, they are all the surrounding concepts. So, which is why it is predicting with a higher probability that you are mentioning this correlated words. And of course, how does it come up with all these correlations and also the entire distributions between words? It's because it is being trained on text and all the different articles and all the Wikipedia, all the text that you provided it. So it's basically trying to piece together the patterns between them. But the thing is, does those inherent patterns that are within those data actually represent the actual world model that we see the world itself? Absolutely not. Because the thing is, although LLMs, they're very good at coding content generations, just because it is trained on the same pattern all over again, but it struggle at higher level tasks like planning, causality, cognition, and reasoning. So yeah, and because of all this downfall of LLMs, high stake industries and use cases like even in medical and healthcare domain, they are struggle to actually implement and rely on LM fully 100% to actually solve their problems. Obviously, when you visit a doctor, you definitely don't want a AI to go through your medical report and then tell you, you have all this XYZ problems. You definitely don't want that. You want a human expert, an actual doctor, to review your medical report and then actually tell you that, okay, correlate, and then provide you a diagnosis. And this is a book written by Gary Marcus called Taming Silicon Valley. In this book, so Gary Marcus, he is actually a very influential and very big name in the AI space, just like Yang LeCun, Joshua Bengio. All these are the big names in AI. So in his book, he sort of laid down, these are some of the biggest risks in generative AI. Disinformation, biases, discriminations, da da da. So this is long list of different risks that are associated with generative AI. And yeah, more literature are supporting the long list of failures from language model. For example, limited accuracy in complex decision support requests. ChatGPT only show up to 56% accuracy in medical queries. That is not good enough. Basically, 56%, you might as well just toss a coin, 50-50, you know? So it doesn't provide that sense of reliability that you want to have on a system. And then, of course, inability to handle and follow guidelines, because LMs, they are all trained to the certain snapshot. When you ask ChatGPT right now, what is your knowledge cutoff date? It might say, I'm fully trained to up to the data to last year, 2024, that's it. So anything, any new knowledge or new information that is beyond 2024, it might not be able to tell you the latest information. And of course, lack of domain-specific expertise, because it is again trained on general purpose domain, and because of that, it also has the potential of generating harmful and biased content. So, so what do we do from here? So we recognize that there are a lot of risk associated with generative AI technology in nature. So what do we do next? What is the research future? What is the trend, and what is the direction? So as we enter what DARPA described as the third phase of AI, we are increasingly moving to more symbolic nature. So we are moving from statistical to more symbolic approaches, like neurosymbolic AI, and also looking for ways to actually combine the merits of both worlds. Because at the end of the day, we have to recognize that LLMs in general, like ChatGPT, they are very good at this moment, they are good at language understanding, not to the certain highest degree, but good enough for a day-to-day non-critical domain task. See, we have to recognize that. But how do we push that kind of edge to a higher accuracy? And this is when the role of knowledge is becoming more critical in making sense of this data. So yeah, this is just the overall evaluation timeline, where we started off with expert systems in the 80s and 90s, where we all rely on logic and rule-based AI. This is where you have decision trees that are more of an if-else statement. So if you're at this decision point, these are your branches, and this is how you proceed from there. This is more very rule-based and logic-based. Then moving on to more statistical machine learning, where you are asking the model to learn from your data. This is more on the machine learning era. Then after that, now we are moving into a more enterprise AI with more hybrid solutions, which is the meat of this presentation here. How do we leverage the LLMs with the knowledge that the human curates and combine them for a hybrid neurosymbolic AI, which is a rapidly emerging field of research. So this is, again, just to show you that this is from a Gartner report showing that knowledge graph has been on the peak of the hype cycle. And yeah. Okay, so this is one use case for study. So let's say you have all these medical reports or even medical documents from FDA. This is a FDA medical device document where you have all the paragraphs or different documents. So do you think it's easier for a human or even for a computer to read through thousands of pages of documents? Or is it easier to make sense of them when you turn it into something like this on a graphical format, where you can sort of quickly visualize and see that, okay, there's a link between these different concepts, and these are some of the relations that are associated between these nodes. So I mean, the research world, it's up to debate whether you feel like just going through the documents, it's beneficial for you, or turning the knowledge graph. But in our research group, we are actually advocating on the knowledge graph side, just because um, in LLMs, there is something called a memory space or a context size. If you look at LLMs, when you feed it a bunch of articles or a bunch of information, it often hit something called a context size, where it kind of loses track what the beginning conversation is. Like for example, if you ask, what is let's say the LM is reading the summary in the beginning of documents, and then you feed it thousands of pages. Towards the end, when you prompt the LM, ask, can you recall what is the first page? What is the summary of this article? It might come up with something, because now the attention space, or even the context itself, the window, is now shift towards the middle and towards the end, and the earlier pages is being decay in that sense. This is in essence how language model it's being built for. It's not a flaw, but rather this is the limitations, because as computing resources, we have to limit a certain size, and context size is the one that's limiting the performance of the language model. So ours, yeah. Go ahead.
So I have a question. Like when you have if you've ever used Copilot,
Yeah.
it talks to ChatGPT, but it has like an 8,000 character max
Yeah.
in a specific chat window.
Right.
Is there a way to change that parameter, or can you like buy a better version of Copilot?
It's actually, yeah, yes and no. So yes, as in maybe Copilot, Microsoft themselves are limiting that is the business marketing side. Like they want you to give you a very little space for you to play with. It's more like a free trial to get you hooked. So with the 8,000 characters, once you get the sense of what it can do, then you feel like, oh, I need more. Now I'm like hooked. I need more context size. But that is purely on the marketing and business side to get you in to buy into the subscription. But the overall picture is that language model has a max cap of context size. If you quickly go and Google GPT model context size or even context length, um, so it says GPT-4 is limited up to 128 tokens. So which means anything after this, it will kind of reset itself. Like the brain itself is max capacity. So it will prompt you to either start a new conversation, or it will have a sliding window that move to forget some part of the conversation in the beginning and move towards the middle and towards the end to clear up some memory space to accommodate the more latest conversations. Yeah, this is the design itself. So, of course, now there is a research field that raised in expanding the number of the size of context that the model can support. So Google Gemini can support up to 1 million, which is a lot compared to 128 tokens. So now the big companies like Google and even Claude, they are Anthropic, they're all competing with each other. So because now they are hitting a cap in terms of how many parameters that it can fit into the model. Let's say 7 billion, that's the max. And now they have to find ways to innovate beyond just brute forcing and just training the model. One of it is to play with or hack the memory size. And yeah, so that is the race there.
So you're at South Carolina. Are you working to build knowledge graphs inside of an LLM, or are you trying to build your own?
Yeah,
Like we talked about SLMs a little bit.
Yeah, correct. That's a good question. So the thing is, what we do here, our role is that how do we clean and pre-process this information and link it with actual human curated knowledge sources before giving it to the LLM, before prompting, or in some cases, even using this graph to train the LLM itself. So we are not tinkering with the inner workings or architectures of the LLM. Often than not, those LLMs like the one GPT-4 or GPT-5, they're all proprietary. So they are all closed source. We have no access to the inner workings unless OpenAI decided to like, hey, we open source. Even if they do that, they're probably gonna open source the older version for you to play with. But how do we keep in advance with the models that are releasing? Is to have our own knowledge repository that we train on, that we have control of. Then we kind of use that to pair it with the LM itself. So yeah.
Yeah. So you had mentioned about the context window of
Yeah.
log form, and you said that as we start uh, increasing the amount of data we give it during inference,
Yeah.
the context window starts getting populated and
Yeah.
it hits a threshold
Yes.
beyond which it might, like the recall abilities or
Yeah.
the token prediction might take a hit
Yes.
on performance.
Yes.
So, what is the trade-off of even increasing this context window? Like, if that was the one-shot solution for,
Yeah.
preventing hallucinations, every research lab would have aimed for just increasing the context window.
Yeah. Because context window is not something that you can just. It's not a hyperparameter space that you can just expand, because that falls back to the transformer architecture itself. So of course, these big companies, they have innovative ways to turn um, to maximize the space, maybe by different chunking mechanisms and stuff like that. But yes, to answer your questions is, so once it hit the max, you can actually see the output. It's kind of decreasing, like the output and performance, and it's taking longer time to sort of reason. So, which is why once you hit a cap, ChatGPT will kind of prompt you, "Hey, I'm hitting my max limit. I encourage you to start a new conversation with a blank space, so we can start from scratch." So now the thing is, as a researcher or someone who wants to retain all those prior contexts, how can we do about it? So, if you continue on that same conversation space, what OpenAI behind the scenes is they are doing is they are making summaries of that conversations. They are making a quick summary, and then now they are resuming from that summary they have created, and then to free up some context space for you to continue chat with. If you uh, insist of staying on the same chat window, so behind the scenes they are doing summary. So, and what we do here is that we try to take it out and formulate it as a knowledge graph to store in our own graph database, for example, to retain the this sort of information and knowledge. But yeah.
The fundamental thing you need to appreciate is that with generative AI, with LLMs, you're dealing with data. And the data is mapped into vectors and parameter space, high-dimensional parameter space. You can't get back to the data from that data. That's it. Of course, you do inference and you can have next door prediction kind of thing. Now, when you say you increase the context window, suppose in the context window, I can provide this whole page. I can provide a whole chapter. I can provide the whole book because you can have context window of 10 million tokens, right? But for your question, your query, what exactly is relevant from that text? Maybe it is somehow there, and an intelligent person can find what is there. But how would a vectorization find exactly what is relevant to improving the query response? Instead, if the context is specified in terms of highly qualified knowledge that is directly relevant to enhancing the understanding or interpreting your question, then the engine will have a lot more quality of information to work with. So the point here is that with data you can only do so much, and system is this transformer or any other models are really good in getting that data and learning from that, but that is not nowhere close to have specific knowledge, especially one that is in the relationships in the knowledge graph. Right? And this relationship may be specified in the text in the, not necessarily in consecutive words. It may be somewhere acknowledged. Here it is qualified, and it is curated and it is high quality.
So are you using like spiders to like go out and search like National Science Foundation documents as an example, and building your own knowledge graph? And what tools do you use for something like
Okay, yeah. So I'm gonna get to that.
that? Okay, I'm sorry.
The inner workings are how to actually construct a knowledge graph. I'm gonna probably in the next few slides. Yeah,
Okay.
but yes, I'll get to the technical part. Yes. So again, this is a sort of a slide to sort of introduce what we do here at the AI Institute. Is the neurosymbolic system where we try to combine both the system one and system two. So system one is the quick reactive framework, just like a language model. When you ask something, it just spit out the answers based on the probabilities, based on list of probabilities that it has trained on. On the other hand, system two, it's more symbolic, that is more deliberate thinking and reasoning. So it is going through the knowledge repository, like for example, knowledge graph, to look for the more relevant graphs or answers to your response before coming out with a more tailored response to your questions for a more critical domain like medical field or healthcare for decision making. So yeah, that is in a nutshell in a broader sense, what neurosymbolic approach is. Of course, yeah, building knowledge graph. So now let's switch gears and look into how do we actually go about building a actual knowledge graph. So at the AI Institute, with Dr. Shed, we have a lot of years, over 30 years of building knowledge graph. So if you want to go and check out the AIISC wiki page, this is a summary and also a detailed index of all the different graphs and different use cases that we have created over the years for different applications for summarization, extraction, personalizations, autonomous driving, drug abuse. We have different graphs for different use cases. So feel free to check out after this seminar. It's our wiki.aisc.ai. And then, yeah, this is again building knowledge graph using both the symbolic and the generative approach, which I'm going to show here in a bit. Okay, so this is a approach on how you actually build a knowledge graph from the beginning. So this is one example that we actually built. This is a pharmaceutical knowledge graph with over 6 million triples, 1.5 million nodes, and more than 3,000 relation types. So combining all the different authoritative sources, like from Mayo Clinic, UMLS, Drug Bank, DBpedia, Wikipedia, and Consonant, for example. So we have developed a platform, which I'm going to showcase in a bit. It's called Empower, that has the ability to create knowledge graph and also from your unstructured data, like the documents, and also linking them to external knowledge bases that are relevant to your data. Like for example, in this case, this is a medical data. So we are linking it with all the different authoritative sources. And for example, you can see here ConceptNet, Drug Bank, etc., Mayo Clinic. So the step to actually create, this is a very sort of high level, and this is usually the blueprint, how one go about building a actual knowledge graph. And this is the knowledge life cycle. So we have at the bottom step one, where this is more of a design choice. So so this space is more like designing and sort of designing requirements design. What are your data sources? What is your downstream task? What are you trying to address? And what are the sources that you have, unstructured, structured, or even semi-structured? So once we have all those requirements kind of gathered around, so the next thing is how do we want to identify what are the external databases or even knowledge bases that are relevant to what we want to do. So in this case, a pharmaceutical knowledge graph. So these are the different external knowledge bases that are highly curated by humans that we can use to make sense of the data that we collected in step one. So this is on the step two is the enrichment process. Once we have this, linking the data to the concept in the data to the external knowledge bases, then we have a graph, we store it, and then we also not just a one pass. So building a knowledge graph is not a one-shot process. It involves multiple iterations of refinement, because let's say you're building a graph from, let's say, 10 documents, 10 unstructured data. that is coming from different sources. So let's say in document A, you have a concept that says lung disease, for example, and then you have document B that says pulmonary disease. So we know that based on the Mayo Clinic, for example, or even UMLS, metathesaurus, it is a metathesaurus in this case is the synonyms of all the medical terminologies. So in this UMLS, it is saying that lung and pulmonary, they're actually referring to the same thing. They're just, one is more layman term and the other one is more medical term. So how do we do the refinement and to do entity resolution? How do we refine them and point them that say, yeah, this is the same concept? So that is mostly on step 4, where you refine the knowledge itself. And then of course, step 5 is continuous updating it with more information as we kind of grow our data sets and to maintain it and continuously update it. So this is a sort of a high level steps in the knowledge life cycle. So again, this is some of the different the sort of information or knowledge bases that we have. So in Wikidata, this is what we have access to, like in terms of drug, there's like the lethal dosage of a drug, what is the medical condition is being treated for this drug, what are the significant drug interactions. All this, you can never find it, everything all in one specific document. It usually is spread across different documents, and Wikipedia provide a sort of a one-stop shop for us to have all this to use to leverage them to make sense of our data. And then if you look at Drug Bank, similarly, Drug Bank has all the information about drugs and so on and so forth. So this is how we actually go out and sort of gather and build our knowledge graph to augment the data that we have. So I'm going to give more examples in a bit. Yeah, so this is the Empower platform. So I'm just going to quickly go over and just show you the platform itself. So this platform, Empower platform, is something that I built over the course of my PhD journey. Basically, we sort of identify there is a gap and also there is a missing puzzle pieces that we want to address in the research field. Because it's easy to build a knowledge graph, but it's not easy to build it in large scale where you are ingesting sources, data from different sources. And also for different domains. And we are building a one-stop solution to address that. So for example, let's say you have a bunch of text, just a text data, and then you turn it into a graph. You can save it. And then the thing is, I can have a one-click enrich wiki data. So this is this graph. This is a first version of the graph that is created from the text itself, the text document. But now, let's say I want to link or enrich each node over here with external sources. Let's say, for example, in this case, Wikidata, for example. Then, in this tool, kind of have that to enrich the concepts that I built based on just the data, just from the text data. So now you see that you are not getting information not only from the text itself, but rather you are querying the external knowledge bases. Now your graph is more comprehensive and more complete. You can see like material testing is said to be same as this concept from Wikidata. And this concept is a subclass of different kind of entities here. And material testing is a subclass of analytic chemistry technique. So this subclass of all these relations, you will never find it in the document text here. And this is something that we want to leverage on. This is what we call the neurosymbolic approach, where we have the neural part that extract the entities, create the first version of the graph from our text, and then the symbolic part comes from the human curation knowledge. So of course, this is one example of creating a graph from just one document. And then what if you have multiple documents? Let's say I have 10 documents. Now I want to merge them. So this is also have a tool. Let's say I have multiple graphs that is being created here. And then you, of course, merge it. We have a different methods to do the merging part. But of course, this is a topic for another day because merging, how do you merge them? How do you find similarity between concepts? This itself is actually a huge research topic itself. You can look it up. It's actually called a graph alignment problem. And of course, let's say you have a more detailed and niche questions or even downstream application that you want to solve, that you don't really need the entire graph. You just want a subgraph, just a one small piece. So let's say you created a graph, and let's say I'm only interested, let's say in the production part of the graph. So I'm gonna click this. Let's say I only want two neighbors, and then this is quickly, boom, you get a subgraph that is tailored to your question that you can just feed it to the language model itself. Yeah.
So when you're first parsing text,
Yeah.
how are you picking out the keywords? Are you going against your own dictionary?
It's multiple ways, but in general, we are relying on the generative nature of, for example, ChatGPT, for example. This is one approach.
Okay.
So ChatGPT, because we also have to recognize it is somewhat good at recognizing some entities, and we use ChatGPT for the first pass. But then, of course, it's not complete, and this is where we have a second step where we put in our own.
You enhance it.
Yes, exactly. Yeah.
So how does ChatGPT give that? Is ChatGPT giving you the tree back, the initial tree?
Yeah.
It is. Okay.
Yeah.
All right.
So does knowledge graph can perform convolution itself?
What do you mean convolution? Like what kind of convolutions?
Like it's only the storage of the data, or it can perform some like neural
So-
network performance.
I see. So when you say convolution, are you trying to turn it into some form of embeddings, like training it?
Yeah.
Okay. So no. So the representation of a knowledge graph, it's actually not in a convolution space. Like it's not in a vector space. It's not. It's actually a formalized representation in a triple form, in an RDF form. That is a resource descriptive framework. It's actually part of a semantic web specification. So it's actually a rule. It's a formalized specification of a rules, and it's not directly in a convolution. But there are ways to turn those rules into convolutions by using embeddings approach, like knowledge graph embeddings, to do that. Yeah, there are many ways to do that. Yeah.
So once you enhance it, are you giving it back to ChatGPT with the enhancements?
No. So the
Okay.
next step, good question. The next step is to present it to the humans for reviews. Like now, I'm going through, seeing like, okay, are this enhancement good enough? So, and now the options, now you quickly see, now it's up to the user. What do you want? Do you think this graph is good enough? So now, because it's a two-way feedback, we cannot just rely on ChatGPT and my enhancement to tell you that, oh, this graph is good enough. Because ultimately, the users who are using this knowledge graph have to decide for their downstream applications whether the graph that is being generated is good enough for them. So we provide that option for you to edit, update, and even delete and update all the different nodes and make changes to that. And then if you think that this version is not good enough, you go and then you kind of enrich it again. You keep on doing to the point that you are satisfied enough, and then you can export it, and then you can do whatever you want with it. So maybe you put it in a graph database, visualize it, or even turn it into convolutions, turn it into embeddings.
So if we take a different example, I just take
Yeah.
NFL teams.
Okay.
And put that in ChatGPT.
Yeah.
It'll create the knowledge graph for
Yeah.
you. You can link to Wikipedia and get their records.
Exactly.
And how many Super Bowls they won.
Yeah,
and stuff
exactly.
like that. But how do you get that to a usable form? So if I have the Pittsburgh Steelers in the text, and
Yeah.
it's highlighted in green, do I click on it and then it gives me the enhanced form, or are you just talking about the graph?
This is at this stage. This is just at the graph form. So how
Okay.
would you want to use it is you probably want to export it, and we have different formats. Let's say I want it to be a JSON format. So when you click on this, you export the graph in a JSON format. Then you can bring this graph to augment the ChatGPT response. Like, hey GPT, I have this graph being generated. Use this graph as your reference guide. Answer the following questions, for example.
Okay.
So because now you provided a knowledge graph reference point for ChatGPT to work with, instead of you're now forming a playground or even constraining the space for ChatGPT to refer to, instead of ChatGPT having to search the entire web or even rely on outdated information about the player that you're interested in, for example. Because
Okay.
now you're created, you have latest information about this player. You are just asking ChatGPT, hey, look at this, refer that, and give me the response.
So that's what they meant last week when they were talking about the medical data that they can increase the accuracy to like 100% by doing something like this? Is that how they were training?
I'm not aware of the last.
They were talking about in context learning.
Yes.
last week.
Okay, I got you. Yeah, in context learning essentially means you're providing the context for during inference time for the ChatGPT itself to learn on the fly.
So that would be like this?
Yes.
So
yes.
this would be a form of ICL?
Yes,
then?
exactly.
Alright, that's
This-
cool. That's what I thought. Okay.
Yeah. This is a form of in
Just for their
context.
information, in the last class we talked about ontology augmented context.
Okay. Yeah. Anything that you provide the ChatGPT during prompt time and inference time, these are all in context learning because you're asking the model to learn it and reason it on the fly, like in context. Yeah, you learn it on the go. So yes, this is a form of in context learning. Yeah, but we are more on the foundation, like we are building the context itself. Yeah.
So is the in the knowledge graph we will only from structured data or any sort of
Any
and unstructured semi-structured?
any structured, unstructured, semi-structured, any form.
The
Yeah.
source of knowledge can be in any form.
Yeah.
That's cool.
And here, Joey's empowered platform uses variety of NLP techniques on unstructured data, extracts from semi-structured data, and of course structured data. And then once you extract the knowledge, you have to add to the existing knowledge graph. So you have to align, and that's another very hard problem to solve. So that data coming from overlapping knowledge coming from multiple sources is cohesively combined. That's another very big problem that you have to solve. And this is not a toy. This is real world.
Yeah, if you want to try it out.
tool.
Yeah.
As you said, we had a $500,000 project from a company working for pharma and maybe what 9 million people solved 1.5
6 million.
6 million people solved 1.5 million entities. Knowledge graph was built of very good quality. And basically, after you build the knowledge graph, main thing is that you need to curate or verify, because there is no technique for extraction is 100%.
Yes.
So especially from text, it's not 100%. So there may be errors, and so you need to handle that. But being able to identify entity identification is the easier part. It is organizing them and finding the relationship and giving the relationship correctly. That's the harder part. Beyond that, you can still enrich these to add constraints and all that as you do in the ontology design language such as R, which is what we don't do. Those things are not found to be scalable as well so far. So this is a happy medium between highly scalable and high quality knowledge creation. And then, if you're interested, go to my LinkedIn page and articles. And you'll find about 15 articles on knowledge graph, and variety of application. For example, there is a version, example. Just yesterday, paper came out on multimodal knowledge graph. So knowledge graph where you have images and other media, for example.
Now, can you do the first step here too, like front end Copilot or front end the ChatGPT context window?
Yeah. Oh, I mean, yeah.
Like, are you sending it API calls to ChatGPT?
Yes.
Okay.
Yes. Yeah. Now, of course, in our platform, we definitely want to have a one-stop shop for everything. We have the insights. Basically, I want to load a graph. Let's say this one. Now it is telling me the different graph properties. This is the density, how sparse it is, what is the connected component, what is the average connections per entities. These are the most connected ones. You can quickly click on it and kind of see through what are the connections. And then now what we have is a sort of a chat assistant that you can converse with the graph and say, hey, tell me more about this graph, for example. And then now you can ask questions. What is the graph about, for example? So now it is going through answering questions and then provide you more insights. So now you are sort of asking the graph, hey, do you think this is the response? So you can see that the knowledge graph is centered around the development, validation, and approval process for a specific medical device, in this case, under the framework of PPAP and da 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 da. So what are the key aspects that is covered in this graph? You have orders, da 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 da. So if you don't want to just, because sometimes graph can get very big, like sometimes it's hard to see, and you can ask, we have a sort of assistant that you can talk to kind of quickly get you up to speed what exactly this graph talk about, and you can ask question, does it cover this specific entity, for example? So yeah.
That's great. Now, can you use this like as a UI to like an SLM as well? Like you do the first pass through ChatGPT and then
Okay, yeah.
do your own upgrades from
Yeah,
there?
so that is definitely in the work in the pipeline. So we have another project. It's called C3AN, Custom Compact and Composite System. That is where we want to leverage the graph and use it to train a small language model, for example. That is in the work actually. Yeah, yeah. Your ideas are actually valid because we have published an article on that C3AN. So which I'm gonna. It's actually right here, the end of the presentation, which is this one, the custom compact and composite AI model, where we use our knowledge graph that we built to train a small language model. So the reason is because we want, in this framework, we want the agent at the end, or the system itself, to be able to deliver on these 14 pillars that we deem the most important factor that deem the language model worthy enough for any critical applications or critical use cases. First is the reliability. Reliability. So does your response or the system is dependent enough, have error-free operations that is robust? And then is it consistent enough with the coherent enough with the output aligned with what we want it to do? Is it consistent? And then alignment, ensure the outputs adhere to the user goals and also the domain requirements. And then so on and so forth. You have analogy, abstractions, causality, instructability, reasoning, planning, rounding, attributions, interpretability, explainability, and safety. So all these 14 elements are what we identify to be the most sort of crucial foundation elements for any systems to be able to provide or deliver to what the user applications. Um, so that is what we identify. Until then, so far, we have not seen any systems out there that are able to fit into any of these 14 pillars. So if you want to talk about the current ChatGPT, uh, is it good enough? It is is it trustworthy? You can never really prove that. Is it safe enough to use? Is ChatGPT safe enough to use in medical applications? Can you guarantee that? We cannot. So there's a lot of different aspects that we want it to be. So hence we have this paper. This is the C3AN framework that we are working towards. So yeah, good question. Let's see. We have a few more time, so I'm going to quickly go through a few remaining ones. So this is just the video that was showcasing the different the tool itself. So I already shown that, and then yeah, okay. So this is more of the behind the scene, how empowered the whole architecture is already published as a paper. So if you look up the link here, yeah, you can definitely give a read into the inner workings of how we design the system, the Empower system itself. But basically, in a nutshell, is that we are combining the knowledge extraction from the language model itself. We recognize we have to give merits to them, and then of course, not every extractions and the curations are always accurate. So this is where we have to come in and step in and enrich it and refine the knowledge that's been created with our own human expert curated knowledge bases that's out there that we can just use and augment it to deliver its results to a downstream application. But overall, this is just the data architecture for do that. So since we have a couple more minutes left, I just want to quickly go through one concrete example here. So how does one turn an unstructured data input to a knowledge graph in this case? So let's say you have a question answering scenarios. So in this medical question, how does methotrexate treat rheumatoid arthritis. So this is your question. This is all you have. This is your context, and that's it. So in order to turn this and look for the relevant knowledge to answer this question, you have to require additional context. What does the word methotrexate means in this case? So we based on this question, we are actually building a mini subgraph to fetch the relevant context and relevant for this question. So we have the ingestion where we take this data, extract the relevant concepts and relations from this question itself, and then we enrich it with the external knowledge bases. Let's say Mayo Clinic or Wikidata. So now we have more surrounding information about this drug itself, methotrexate. It has the different brand names and it has different product ingredients. You can also expand on the product ingredients. Is it safety or does it have any drug and drug-drug interactions, existing ones that is conflicting with the current drugs they are taking, and so on and so forth. So yeah, this is more on the detailed step on how you actually link them. But I'm going to just walk through a notebook. It's all easier to see there. But basically, this is the process where we identify the key triples relation entities. We link it to a authoritative sources. For example, in this case, drug bank, where it provides more information about this drug, methotrexate. There's different brand names, their background, what is the associated condition with this drug, what is typically used for, and what are the product ingredients. And now we have more context about this specific drug, which can then feed it to an LLM, say, hey, this is additional information. This is my in-context learning. Learn it and try to give me a response. And so the process can be split into 5 different steps. You have ingestion, and then you search and integrate the existing knowledge bases. You enrich it. Basically, you're uplifting the data to the knowledge part. Remember the first slide where we have the DIKW pyramid, where we go from 150 value all the way to hyperthyroidisms. So that level of uplifting can be done by the use of knowledge graph. So let me just quickly run through a notebook just for you to see at a code level. So all these are all public and open source that I put in on GitHub, which I have links to in this slide. If you're interested, you can just click on it and play with it. But this is being delivered as part of a tutorial session for IEEE Big Data Conference last year. And so we have the 5 different steps. So the first one is data ingestion and extraction with LLMs. Basically, you're asking the LLM, hey, just just identify what are the key entities and relations in these questions. And then I was able to identify that methotrexate is a medical condition treated, this, and then this. So that's all it's going to get. Like, this is what the level 1, like the seed knowledge graph, seed graph that's being produced. Now, then once you have this initial information, now we linked it to a external knowledge bases. For example, in this case, I'm linking it with a Wikidata, for example. So now in Wikidata, it is linking to the corresponding Wikidata ID, Q4222232. If you look up this Wikidata, you can actually get this entity itself. This is a methotrexate chemical compound, and you have all this information here, instances of subclass of this drug. It is part of a cellular response to methotrexate, and all this chemical structure, medications, all these different compounds, and all this extra human curated high quality medical knowledge that are out there for everyone to use, and what are the medical condition treated. See all these different ones. So you get access to so much more than what you've seen in just one specific sentence or even question. So this is the power of using external knowledge to deliver what we want it to answer. So then coming back to the question, so you link it with the corresponding ID, you sort of uplift it to more surrounding information and also knowledge. So this is the entire graph. Now you got more. Basically, this is all this format in JSON is actually all this right here, all this external, all this right here. And then now we quickly see how the graph has expanded a little bit more. And you can see that methotrexate is a link to a Q42232, which is a Wikidata ID, and which is part of, and it has all these chemical formulas and different response, as you can see. Now, with all this, we can use it for in-context learning, for a ChatGPT, for example, and use it and, hey, tell me more, and use that to answer the questions, the original questions that we have, which is the how does this drug treat rheumatoid arthritis? This is one smaller use case to showcase the process of creating a mini subgraph from a question itself. And of course, this is the platform if you want to deal with all on a larger scale and merging, of course. And yeah, so I guess we are at time. This is the so what are the more broader impacts and applications and use cases of a knowledge graph? So I just kind of pointed it out, which is the C3AN platform, the custom combined composite AI system for Enterprise 4.0, which focuses on the 14 different foundation elements that are critical for any medical, which is critical for any critical domains. And yeah, you can find more about this topic on these different links on our websites, on even our wiki page. So yeah, at 3:15. So yeah, I open up the floor with any questions. Yeah, go ahead.
I'm sorry, I have too many today. So if I have a corporation,
Yeah.
they have their own customer care wiki.
Right.
Can you import something like that or enhance from something like
Yeah.
that?
Absolutely. Absolutely. Yeah.
And Empower itself, is that intended for the university to use, or are you intending to
No.
make a company out of it? What is your plan?
My plan is open access for everyone to use it.
Okay.
That's the goal. Because we want to be recognized as the sort of a one-stop shop for building a graph for any use cases that you want to use.
So
Yeah.
if I wanted to build my own enterprise customer care and I have my
Yeah.
own wiki,
Yeah.
I can plug into you and do the rest of the
Yeah,
process.
if you can provide with all the different sources, your text, your website, PDF, or even stuff. We are slowly expanding the support to databases, like SQL or any external databases. But for now, this is what the different formats that we are supporting. So if you can provide with all this, you can definitely generate a graph that is tailored for your use case. Yeah. And then of course, if you're unsure how to actually like go create the graph or itself, so we have a schema maker, which we call the ontology maker, which is essentially the schema for the graph itself. So like for example, in this case, you see that the graph here that says, let's see, yeah, so computer benchmarking is the instance of economic activity. So this is at the instance level, but at a higher level, what is computer benchmarking? It could be a technology concept. So you have a technology. Technology can be an instance of an activity. That is an ontology, which is a schema. So yeah, and then of course we have insights where you can just kind of go back and forth with the assistants and kind of ask questions back and forth. And then if you feel like this graph is not complete, you can do more generations. And then at the end, you have multiple graphs. You can combine all of them, different versions, because now essentially you just treat every different version of your graph as a subgraph that is generated from different sources. You have document A, document B, document C. Now you just kind of want, because all your data and information are being spread across from different documents, and you want to just put everything together, boom, and one graph. And then you can do that with the graph alignment and merging option that we have. So now you have just one graph to work with. And then if you feel like the one graph is too big enough, then you want to focus on one or few specific entities like this, and you want it to, let's say, on a two-hop basis, you just extract what you want and provide that as an in-context learning for any language model, ChatGPT, for example, in this case. Yeah, that's the idea here.
Excellent work.
Sure. Thank you.
You can show, your Empower page just in case somebody wants to.
Okay. Let me just log out.
Is this service only available through the dashboard, or can we access it through some sort of API?
Actually, both. We have both options on this and also the API. So it's at the documentation. So yeah, this is the main page, but there is actually an API documentation page that you can actually look up. Yeah, this up. So this is the main page itself with empower.com. So yeah, this is just the front page for it. And what are the different tools that you can use? And yeah, so
I think the AIISC page.
Oh, okay. Yeah, so this is the AIC wiki page, and these are all the different projects. And then knowledge graph is right here, and then my two page is right here. So AIC knowledge graph, this is a page that provides all the knowledge graph experience that we have throughout the entire year that we are working in this topic. As you can see, all our prior seniors who are graduated, and these are their PhD thesis. Everything is up here, and all the publications. Yeah, it's a lot more information that you can just go and look through. So that's a lot more. Yeah.
How big's your team
Huh?
that's working on Empower?
I mean, they started a few members, but most of them are started as interns, so they kind of in and out, and then now I'm the only one that's who is working. But now I'm focusing on publishing a few more papers because I'm looking to graduate in soon. So that is the objectives that I have. But yes.
Excellent.
Great. I think we can. You should go and search for knowledge graph tool.